Have you ever wondered what the future of medicine could look like? Could we possibly print organs just like we print a photograph? Imagine a world where organ donor lists are obsolete, where waiting for a transplant is no longer a matter of life and death. This is the world that bioprinting promises us. By harnessing the power of 3D printing technologies and merging it with the intricacies of biological matter, we are on the brink of a medical revolution. Bioprinting, a term that might sound like it's straight out of a sci-fi movie, is a rapidly evolving field. It's the process of creating cell patterns in a confined space using 3D printing technologies, where cell function and viability are preserved within the printed construct. This isn't just about creating a replica of an organ, but a fully functioning, living organ ready for transplantation. If this sounds like science fiction, let's journey together through the evolution of bioprinting. Our journey begins in the early 2000s with the inception of bioprinting. Imagine a world where organ transplants were as simple as printing a document. Sounds like science fiction, right? But this was the vision that sparked the birth of bioprinting. In its early days, bioprinting was a far cry from what we know it as today. The first experiments were simple, yet groundbreaking. Scientists began by printing thin layers of cells, a task that was as delicate as it sounds. The challenges were enormous. Cells are sensitive, fragile things. They can't survive just anywhere. They need the right conditions, the right nutrients, and the right neighbors. Creating these conditions outside of a body was no small feat. But with every challenge faced came an opportunity to innovate and create. As the years passed, the technology developed. The bioprinters became more precise, the bioinks more sophisticated. Thin layers of cells became thicker tissues, and eventually the first bioprinted organ was created. A simple bladder, perhaps, but a giant leap for medicine. The process wasn't perfect, the organs weren't always functional, and the technology was expensive. But the potential was clear. Every failure was a lesson learned, every success a step closer to the dream. From rudimentary beginnings, bioprinting has come a long way, yet it's still in its infancy. But as we'll see, the future of bioprinting is full of promise and potential. Fast forward to today, where bioprinting has started to make its mark. It's no longer a concept confined to the pages of a science fiction novel. It's real, it's happening, and it's revolutionizing the field of medicine as we know it. One primary application of bioprinting is in the realm of tissue engineering. Scientists are now able to print layers of cells to form various types of human tissue. This breakthrough is paving the way for the development of personalized treatments, as doctors can use patients' own cells to create the printed tissue, reducing the risk of rejection. But that's not all. Bioprinting is also making waves in the field of drug testing. Instead of testing drugs on animals or humans, pharmaceutical companies can now use 3D printed organs to assess the effectiveness and side effects of new treatments. This not only makes drug testing safer, but also more efficient and cost-effective. Among the most impressive achievements to date is the creation of a mini human heart, complete with all its intricate structures and beating cells. While it's still early days, such advancements hold the promise of creating fully functional organs for transplantation in the future. As we stand on the cusp of a new era in medicine, the potential of bioprinting is only just beginning to be realized. The future holds exciting possibilities, and we're just getting started on this remarkable journey into the realm of printed life. So what does the future hold for bioprinting? As we venture further into the 21st century, the realm of possibilities for bioprinting continues to expand. Imagine a world where the need for organ donors is a thing of the past, replaced by a time when we can print whole organs for transplantation. This isn't just science fiction. It's a future that scientists and researchers are actively working towards. However, with these advancements come new challenges and ethical considerations. We must ask ourselves, who will have access to these life-saving technologies? How will we ensure they're used responsibly? And then there's the technical side of things. Creating a fully functional organ is no small feat. It requires a perfect synergy between cells, blood vessels, and tissues, all working in unison. But as we've seen, bioprinting is a field that doesn't shy away from challenges. As we look to the horizon, one thing is clear: the future of medicine could very well be printed.